One of the most enticing aspects of the cosmic phenomenon is the potential supernova of Betelgeuse, situated in the well-known shoulder of the star grouping Orion. Betelgeuse is a crimson supergiant nearing the penitentiary conclusion of its life cycle. Unexpectedly, one of the heaven's brightest stars began to dim noticeably, discernible even to the unaided eye. For several months, its radiance significantly diminished, leading many observers to speculate whether the star was nearing failure. Focusing their telescopes on the massive star, researchers were amazed by evidence of significant dimming. Betelgeuse is thought to be on the verge of erupting into a supernova, signaling the conclusion of its stellar existence, but when and why remain unknown. Will this cosmic detonation transpire? Could it have devastating effects on our planet? The brilliant red star, Betelgeuse, can be found on the top right side of the Hunter Orion's shoulder. You might know it by its alternate title, Alpha Orionis, even though it is the second most luminous star in that constellation, following the enormous Rigel. It continues to intrigue scientists due to its fluctuating behavior and distinctive characteristics. Alpha stars in a constellation are typically the brightest, and although Rigel surpasses it, Betelgeuse's brightness draws attention. Because of its huge size and reddish color, Betelgeuse, also referred to as Alpha Orionis, is one of the most well-known stars in the night sky, being the 10th most brilliant and 7th most visible for much of North America, Europe, and Canada. Its designation is derived from Arabic and signifies the armpit of the giant, referring to its position in the star grouping. Betelgeuse sheds approximately 1 solar mass every 10,000 years, distributing substances uniformly in all directions and generating a nebula. This nebula that surrounds it spans 30 astronomical units, or 30 times the distance between Earth and the Sun, and is 150 times larger in size than the Sun. At its very essence, Betelgeuse's hydrogen nuclei merge under immense gravitational pressure, creating helium and emitting radiation and warmth in the process. As the star depletes its hydrogen, it starts fusing helium and carbon as substitutes. When helium runs out, neon combines with carbon to produce iron. The fusion of iron fails to produce energy, leading the star to cave in under its own gravity and eventually explode into a supernova. One of the universe's most forceful explosions. Based on their age and stage of development, stars emit light in various wavelengths, ranging from the intense blue of young stars to the red of older stars. Based on the ancient stargazer Ptolemy, Betelgeuse displayed a color he intriguingly labeled as ruddy. Notwithstanding, early Chinese astronomers commented on Betelgeuse's yellow appearance, implying that it might have been a yellow supergiant at the time. Massive stars that explode quickly burn through their hydrogen, leading to an early demise, even if their existence spans only 10 million years. There is no question that Betelgeuse is in its final phase, while the Sun still has more than 5 billion years of life. Betelgeuse is getting close to its final moments, meaning it could someday erupt in a supernova. However, the precise schedule of this occurrence is still unknown. Betelgeuse experiences the cycles of brightening and fading, one occurring every 5 years and lasting approximately 100 days. The swelling and shrinking of its outer layers within these rhythms cause alterations in its diameter and surface temperature. Significant interest in Betelgeuse expanded throughout its unpredictable behavior in 2019 and 2020, when its light faded dramatically before recovering briefly. Certain scientists have theorized that this strange activity may indicate that the star is close to completing its transformation. Thorough examination of Betelgeuse dates back to the 1st century BC, yet the origin of its dimming remains a complete mystery. Betelgeuse is spotted moving through the interstellar environment at about 30 kilometers per second, having been driven away from its origin in the Orion OB1 cluster, which is home to the stars of Orion's belt. The resulting bow shock extends beyond for light years. Evaluating the red supergiant's proximity and size is infamously challenging in astrophysics because several factors prevent accurate diameter estimates. Moreover, since Betelgeuse is a pulsating star, its size varies over time. This quality, along with the dimming of its outer edge, has resulted in observed color shifts and diminished brightness. As we look more closely, the material in the outer shell expelled by the star plays a vital role in light absorption and emission, affecting how we interpret its brilliance. Directly contrasting views of Betelgeuse is difficult because the wavelength influences the visible size observed. These measurements may fluctuate depending on the component of the light spectrum employed. In July 2009, the European Southern Observatory released images captured with its Very Large Telescope VLT interferometer, a ground-based telescope that revealed a massive gas plume extending up to 30 astronomical units from the star's surface, one of many observed mass expulsions from Betelgeuse. This flow was equivalent to the angular distance between the Sun and Neptune. At least 6 such events have been found around Betelgeuse. These events may provide clues to the concern about mass ejection in the final phases of massive stars, which may be central to their destruction. The complicated processes within Betelgeuse's extended upper layers remain baffling, as does the specific procedure by which red supergiants release their matter. Such stars are essential to the movement of substances within galaxies, and as a result of advances in interferometry, astronomers are looking into ways to solve these riddles. In 2019, scientists utilizing the Hubble Space Telescope and other observatories found that Betelgeuse had lost a significant part of its outer shell, causing a massive ejection of surface mass SME. Solar mass is created by the Sun's ejections. The events of Betelgeuse were 1,000 times greater in degree of extremity, with this theme releasing 400 billion pieces of content heavier than the average solar eruption. This explains why Betelgeuse saw a significant decrease in brightness in October 2019. By the middle of February 2020, it had become nearly 3 times brighter, transforming from a magnitude between 0.5 and 1.7 by February 17, 2020. Betelgeuse remained bright, largely constant, for more than a week. On the 5th, it appeared that the dimming had stopped entirely. However, recent observations showed no decreases in visible light connected to a probable core collapse, as infrared radiation did not change significantly. On February 24, 2020, these observations were registered. Feel free to share your thoughts in the comments section if you found this helpful. For the video, click the thumbs up icon and subscribe so you won't miss future content. When Betelgeuse eventually explodes as a supernova, it will be one of the most significant cosmic events ever recorded. Even at a distance of 640 light-years, the blast will shine so brightly that it may outshine the full moon and even be visible during the day for a few weeks or even months. Experts estimate that the supernova will discharge more energy in less time than the Sun will produce throughout its entire 10 billion-year lifespan. The illumination from the explosion will speed through space and eventually reach Earth as a magnificent single point of light, unlike any other witnessed before. Rest assured, we are completely risk-free. Although a supernova from Betelgeuse may seem alarming due to its proximity, it remains far enough away that Earth's biosphere or living things, whichever you prefer, will not be damaged by the detonation. It will, however, present a remarkable scientific occasion. As of the last few years, Betelgeuse has returned to typical levels of brightness, but it still exhibits irregular patterns of dimming. Scientists are closely observing it, making use of instruments like the James Webb Space Telescope, the Hubble Space Telescope, and land-based interferometers such as the VLT and ALMA. They're tracking patterns in surface light fluctuations, constant mass, convective activity, and outflows that appear to reflect the star's instability. This is supported by the theory that Betelgeuse's significant fading was caused by a huge cloud of floating stellar dust from one of these eruptions, temporarily blocking the star's light from our viewpoint. Grasping the mechanisms behind Betelgeuse could assist astronomers in decoding the life phases of gigantic stars, particularly those close to undergoing a supernova. Such insights could aid in predicting similar events in other galaxies, provide an explanation for how chemicals enrich the cosmos, and detail the formation and dispersion of elements like gold and iron throughout the universe. Betelgeuse is truly a ticking time bomb, a cosmic timepiece winding down slowly. It may explode tomorrow, next year, or in 100,000 years, but when it does, it will present a galactic spectacle and a wealth of scientific data unmatched in today's comprehension of stellar life and death. Stars like Betelgeuse are not just a topic of academic interest. They play a critical role in shaping our understanding of the universe as a whole. Massive stars serve as forges where heavy elements are formed. When these stars complete their life cycles and explode in supernovae, they scatter these elements into space, enriching surrounding interstellar clouds with the building blocks for new stars, planets, and even life. Betelgeuse's impending supernova offers a rare opportunity to investigate such an event in detail. The majority of supernovae in modern science occur in distant galaxies, limiting the detail and data scientists can gather. However, with Betelgeuse in our own Milky Way galaxy, just a few light years away in astronomical terms, astronomers could keep an eye on the explosion at every stage and its repercussions with unprecedented clarity. This possibility of observation is particularly exciting for those studying gravitational waves and neutrinos. When a star explodes in a supernova, it not only emits visible light, but also vast amounts of neutrinos and may produce ripples in space that can be detected. If Betelgeuse were to go supernova, detectors such as LIGO, Virgo, and IceCube could capture this data, providing new insights into both stellar physics and the primary forces that drive the universe. Moreover, astronomers are paying close attention to Betelgeuse not only because of its possible demise, but also because of what it can teach us about red supergiant behavior in general. Betelgeuse and other giant stars remain among the most obscure aspects of stellar evolution, being extremely volatile and difficult to accurately model. Advances in high-resolution space telescopes and spectroscopy are contributing to that change, but many questions remain unanswered, questions that Betelgeuse might soon help resolve. In the meantime, Betelgeuse continues to flicker, pulse, and surprise us. Its brightness may seem steady for now, but scientists remain alert and prepared to capture every fluctuation. In the event of a supernova, the data collected could revolutionize our understanding of how stars live and die. Until that moment arrives, be it tomorrow or millennia from now, Betelgeuse will remain a focal point in the night sky and in the imagination of all astronomers. It stands as both a cosmic marvel and a celestial countdown.